Converting from decimal. In this video, we will demonstrate how to convert decimal numbers to binary, octal, and hexadecimal numbers. We'll start by converting from decimal to binary. The first number we'll convert is 14. Since we're converting to binary, we'll need to construct a binary table. In the top column in the far right will be the first multiple of 2, which is 1. Then we'll put the next multiple of 2, which is 2. Then the next multiple of 2, which is 4, so on and so forth, until we encounter the first multiple of 2 that is bigger than the number we are converting, which is 14. 16 is bigger, so we stop here. Then we can cross out that column because we no longer need it. We're going to focus only on the columns headed by a multiple of 2 that is smaller than the number we're converting. So the first question we ask, starting at the far left column, how many 8s can fit inside 14 without going over it? Obviously 1, because if you have 2 8s, that gives you 16, which is greater than 14. We don't want to go over the number, we want to stay under. So 1 8 can fit inside 14. Next step, multiply the top row by the bottom row, then subtract that from 14. That leaves us with 6. Then in our table, we go to the next column. How many 4s can fit inside 6? 1 4 can fit inside of it, so we put 1 in the row beneath it. Then multiply the top row by the bottom row. 4 times 1, subtract that from 6. That leaves us with 2. Then onto the next column. How many 2s can fit inside a 2? Obviously, 1 can fit inside of it. Multiply the top row by the bottom row. 2 times 1, subtract it from 2, leaves us with 0. Next column, how many 1s can fit inside 0? Obviously, 0 because 1 is greater than 0. That completes our table. And the final answer we get by simply reading off the digits of the bottom row from left to right. So 14 converted to binary is 1110. And notice I put 2 as a subscript to indicate that this is a binary number. It is not 1110. It is the binary number 1110. Next, let's convert 117. Once again, we need to construct our binary table. We start at 1, then 2, so on and so forth until we reach a multiple of 2 that is larger than the number we are converting. That number is 128. Now that we found it, we can cross it out because we no longer need it. We're going to start at 64. How many 64s, if any, can fit inside 117? 1. Multiply the top row by the bottom row. 64 times 1, subtracted from 117, leaves us with 53. Next column, how many 32s can fit inside 53? 1. Top row times the bottom row, 32 times 1, subtracted from 53, leaves us with 21. Next column, how many 16s can fit inside 21? 1 can. Multiply the top row by the bottom row, 16 times 1, subtracted from 21, leaves us with 5. How many 8s can fit inside a 5? None, since 8 is bigger than 5, so we put 0. Skip to the next column. How many 4s can fit inside 5? 1 can. Multiply the top row by the bottom row. 4 times 1, subtract it from 5. That leaves us with 1. How many 2s can fit inside 1? None can, since 2 is bigger than 1. Skip to the next column. How many 1s can fit inside a 1? 1 can. Multiply the top row by the bottom row. 1 times 1, subtract it from 1. Obviously, leaves us with 0. Once we reach 0, we've finished. Our final answer is all the digits of the bottom row read from left to right. Thus, 117 converted to binary is 1110101. For our last binary example, we're going to convert 333. Once again, first step, construct the binary table. Get as many columns as needed until we find a multiple of 2 that's larger than 333. That is 512. We cross it out. Thus, we are now going to start at 256. How many times can 256 fit inside 333? 1 time. Multiply the top row by the bottom row. 256 times 1, subtracted from 333, leaves us with 77. How many times can 128 fit inside 77? 0 times, since it is larger. On to the next column. What about 64? How many times can 64 fit inside 77? 1 time. Multiply the top row times the bottom row. 64 times 1, subtracted from 77, leaves us with 13. Next column, how many times can 32 fit inside 13? 0 times. Next column, how many times can 16 fit inside 13? 0 times. On to the next column, how many times can 8 fit inside 13? 1 time. Multiply the top times the bottom. 8 times 1, subtracted from 13, leaves us with 5. How many times can 4 fit inside 5? 1 time. Top row times the bottom row. 4 times 1, subtracted from 5, leaves us with 1. How many times can 2 fit inside 1? 0 times, since it's larger. How many times can 1 fit inside 1? 1 time. Multiply the top times the bottom. 1 times 1, subtracted from 1, leaves us with 0. Thus, for our final answer, we have 1 0 1 0 0 1 1 0 1. Now let's practice converting from decimal to octal. For our first example, we'll convert 475. The steps for converting to octal is the same as the steps for converting to binary. Only difference is that instead of constructing a binary table, we're going to construct an octal table. That means we're going to start at 1, and then we're going to multiply times 8 every single time until we get a multiple of 8 that's larger than the number we're converting. In this example, that number is 512. Now that we found it, we can cross it out. We're going to start at 64. How many times can 64 fit inside 475? We can figure this out by doing simple division. Feel free to use your basic calculator for this step. When we divide 475 by 64, we get approximately 7.42. Our concern is only with the number to the left of the decimal point. We don't care about the numbers after the decimal point. So we only care about the 7. 7 goes on our table. Multiply the top row by the bottom row. 64 times 7. 64 times 7 equals 448. Subtract that from 475 and we're left with 27. Next column, how many times can 8 fit inside 27? Let's do the division. 27 divided by 8 equals 3.375. Once again, we don't care about the numbers after the decimal point. We only care about the number before it, which in this case is 3. So 3 goes in the table. Multiply the top row by the bottom row. 8 times 3, subtract it from 27. 8 times 3 equals 24. Subtract that from 27, and we're left with 3. Next column, how many times can 1 fit inside 3? Obviously, you can do this in your head, but just to illustrate, 3 divided by 1 is 3. Thus, 3 ones can fit inside a 3. Multiply the top row by the bottom row. 3 times 1, subtracted from 3, equals 3 minus 3, which equals 0, thus indicating that we've reached our last step. Thus, our final answer we get by simply reading off the bottom digits from left to right. So 475, when converted to octal, is 733. Not the decimal number 733, but just 733 base 8. Now let's practice converting from decimal to hexadecimal. We'll start with a nice large round number, 15,000. Once again, the steps for converting to hexadecimal are the same as the steps for converting to octal and binary. Only difference is that now we're going to construct a hexadecimal table, starting with 1. Then we're going to multiply that number by 16 until we get a number that's larger than the number that we're converting, 15,000. And in this example, that is 65,336. Now that we found it, we can cross that column out. We don't need it. First step, how many times can 4,096 fit inside 15,000? We can determine that by doing simple division. 15,000 divided by 4,096 gives us approximately 3.66. We don't care about the numbers after the decimal point, just the number before it, which in this case is 3, so 3 goes in the table. Multiply the top row by the bottom row. 4,096 times 3, subtract it from 15,000. 4,096 times 3 gives us 12,288. Subtract that from 15,000, and we're left with 2,712. Next column, How many times can 256 fit into 2,712? We do the division. 2,712 divided by 256 gives us 10.59. Ignore the 0.59, focus on the 10. 10 is our number. However, in hexadecimal, we use letters to represent the values 10 through 15. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. Here we got 10, so instead of putting 10 in the table, we're going to put the letter A. Multiply the top row by the bottom row. 256 times 10 equals 2,560. Subtract that from 2,712 and we're left with 152. Next column. How many times can 16 fit into 152? We do the division. 152 divided by 16 gives us 9.5. Ignore the 0.5, focus on the 9. 9 goes on the table. Multiply the top row times the bottom row. 16 times 9 equals 144. Subtract that from 152 and we're left with 8. How many times can 1 fit into 8? 8 times. Multiply the top row by the bottom row. 8 times 1 equals 8. Subtract it from 8 and we're left with a 0, thus completing all of our steps. Hence, 15,000 converted to hexadecimal is 3A98. For our last example, we'll do a much larger number, 61,966. For this example, we can use the exact same table that we used for the previous example, since 65,336 is larger than the number that we're converting. It's the first multiple of 16 that is larger than the number that we're converting. So, how many times can 4,096 fit into 61,966? We do the division. We get approximately 15.13. Ignore the numbers after the decimal point. Focus just on the numbers before the decimal point. We got 15, a 2-digit number. The letter F in hexadecimal represents 15, so F goes on the table. Multiply the top row by the bottom row. We get 4,096 times 15, which equals 61,440. Subtract that from 61,966, and we're left with 526. How many times can 256 fit inside 526? We do the division, and we get approximately 2.05. Ignore the 0.05, focus on the 2. 2 goes in the table. Multiply the top row times the bottom row. 256 times 2 gives us 512. Subtract that from 526 and we're left with 14. How many times can 16 fit inside 14? 0 times since it's larger, so we put a 0. Next column. How many times can 1 fit inside 14? Obviously, it can fit inside of it 14 times. 14 divided by 1 equals 14. But we're not going to put 14 on the table. We're going to put the letter that represents 14, which is the letter E. Multiply the top row times the bottom row. 1 times 14, which is 14. Subtract that from 14, and we're left with 0, thus showing that we are finished. Hence, 61,966 converted to hexadecimal is F20E.